Hi, I'm Esther.
And I'm Sean.
I write about AI news here at TechTarget in Massachusetts.
And I edit Esther's stories.
We're here to talk with tech experts about everything AI and ChatGPT.
Don't forget Google Gemini.
Whether it's who's ahead in the generative AI race, the metaverse, digital twins, or even the latest in autonomous vehicles, we've got it covered. Right, Sean?
Yep, we've got it covered. Hello, everyone. Welcome to another Targeting AI podcast. Today, Jamie De Guerre is joining the podcast. Jamie is the Senior Vice President of Product at Together AI. Together AI is an AI company that contributes to open source research, models, and data sets that advance AI tech. Before Together AI, Jamie was Director of Product Management at Airbnb, and he also managed product and marketing for Siri Search and AI machine learning at Apple for a few years. And before that was at Cloudmark, a messaging security company. Thanks so much for joining us today.
Thank you for having me. I'm excited to talk to you both.
We're really happy to have you.
Yeah, we're really happy to have you, Jamie. So, to kick it off, you have such a breadth of experience at different companies. What got you started with AI technology, and what would you say has been the biggest commonalities in all the different companies you worked for at, such as Airbnb, Apple, and Cloudmark?
Great question, Esther. Thank you. So I've been working with AI now for over a decade, and I would say the biggest moment that got me very excited was when we started to convert prior ML machine learning technologies to use deep neural networks at Apple for both search accuracy and relevance, and for speech recognition for Siri. And what we saw was that you could take a relatively small amount of engineering development time and achieve significantly higher accuracy at these tasks using a deep neural network. It was kind of the first time I really saw sort of the machines learning on their own. You could apply more data and more compute and achieve results that now were much better than we could achieve through development, and in many cases were better than a human could do themselves. So that was probably the biggest aha moment for me. And I would say, last year, as generative AI really took off, I was both sort of astonished and not surprised because I had sort of seen some of this coming and seen some of this happening over the years working within the AI field.
How is it different working for a startup, a well-funded startup like Together AI, compared to these big companies you worked for in the past?
It is very different. So I started my career at Microsoft, and then I worked at startups for 10 years. Then I went to Apple for 9 years, following the acquisition of a startup I was at called Topsy. And then now I'm back again working in the startup world at Together AI. I joined as one of the first few employees as sort of the founding SVP product for the team. The pace that things move is incredibly fast in a startup. And the other difference is you help wherever help is needed. And so in my 2 years at Together AI, I've done everything from product management to marketing to building up field technical services and customer support teams, to helping code the website myself, initially on sort of simple open platforms, to helping to move boxes in the office. And everyone sort of takes on lots of different responsibilities in a startup, whereas in a large company, there's incredible systems around you, not only in terms of sort of company systems like HR and office and everything else, but also systems in terms of how work gets done and how decisions get made and approved. And so I felt in many cases, being at Apple with such incredible talent around me, the importance of my decision mattered a lot less, because there were several review steps before the decision was actually finalized, going up through the executives. And that meant that the machine made sure that we were kind of taking the right path, regardless of maybe a decision from one individual. And at a startup, that's not the case. Your decisions really matter every day. And that's true for everyone throughout the organization, because you don't have any of those sort of systems to kind of ensure quality regardless of the individual.
That's very interesting. As you were talking earlier about you saw generative AI come in, I wonder what you mean by that. Can you expand on what did you exactly see coming? Was it that the technology was already underground? We've spoken to lots of people who said, well, obviously we weren't surprised, but how popular it became really fast was surprising. Was that what you mean? You saw that it's going to become really popular really fast? What did you mean?
I meant more from the technical capability side. I think that for those of us kind of working within the AI field for the last decade or more, we've seen constant and significant improvement. The breakthroughs that happened with GPT-3 and ChatGPT were significant steps up. However, they weren't, I think for many of the world that kind of hadn't been participating in the AI field, when you tried ChatGPT, you kind of went from 0 to 100. And that was like a shocking difference and a shocking experience. Whereas over the last decade, those of us within the AI field kind of progressively got closer to the level that ChatGPT was at, was a jump up, but not sort of moving from 0 to 100 with these capabilities.
Let's get to Together AI. So, what exactly do your customers use your platform for and your technology? And what are some of the use cases and applications that they're using it for?
Yeah, so Together AI provides a total platform for generative AI. We call ourselves the leading AI acceleration cloud, and we really hone on that word acceleration because a key benefit that we bring is faster performance and better efficiency, which we think is incredibly important. One of the things that you'll see with generative AI for organizations deploying applications built on generative AI, it's not just a little bit more expensive than applications of the past, it's many, many orders of magnitude. I think we did one calculation that a single request to a generative AI model versus a web server and database application was 100,000 times more expensive. And so, with this difference, as organizations move to deploy generative AI over the coming decade, the cost of infrastructure will have outsized importance. And so, Together AI makes that more efficient and performant so that we can typically reduce the number of GPUs that an organization would need to run for an application by 2 to 5 times. And we do this across both the application building stage, so training or fine tuning an AI model, and the deployment stage, running those models for inference. And we focus on doing that on top of open source models.
I have another question, Esther. I stacked it up this way. So, your mission statement is that the future of AI is open source. So,
Yes.
what exactly do you mean by that? And a couple of other follow ups within that. What makes it open source? And what's the difference between open and open source? Because we hear open thrown around a lot, like Meta is open, but maybe not fully open source. And what's the difference between open source in the age of operating systems back in the old days and open source in the age of generative AI?
Sorry, that's a lot of
Great.
questions.
Well,
Great questions. Great questions.
I added stuff too. Yeah.
Yeah, no, that's helpful though. I think it's a great set of questions and something we think about a lot here at Together AI. So let me just sort of start from the top. We do believe that the future includes open source AI, and when we think about organizations looking to deploy applications on top of generative AI, we think that in the future there will be organizations that do that on top of a closed source model, models like OpenAI GPT-4 or Anthropic Claude. And those models provide today the highest accuracy available for kind of general purpose tasks. However, we think that there's also going to be a significant number of organizations in the future that deploy their applications on top of an open source model. The reasons for this are several. First, this enables those organizations to deploy their application with much greater privacy control. They can deploy it in their own infrastructure because they can download the model itself. They don't have to just call out to a hosted service. They can control where they move that model, where they move any data that the model uses, and they can control where the user's questions or prompts go and where those responses go. So privacy is much greater with these open model deployments. Second, it gives the organizations much more flexibility and control. In most cases, organizations are going to fine tune one of these large models to a specific task. And if you fine tune an open source model, the resulting model is something that you as an organization owns. You control the weights. You don't have to share them with anyone if you don't want to. They're part of your sort of own proprietary secret sauce of your generative AI investment. And if you think of organizations making a significant investment in generative AI, we think that most of them will want to own their own destiny. They'll want to own that future. One example I like to think about is, let's say that you're an insurance agency, State Farm or Nationwide, one of these types of large insurance companies, and you have decades of claims data, sort of customers reporting a claim and then decision that happens and all the data around that. You also have decades of climate data, and you're wanting to invest in generative AI to make the best predictions about whether or not you should insure a particular request for insurance. And your CEO or your board is saying, we need to be the leader at using generative AI to do this, because if not, our competition is going to beat us. This decades of data is your crown jewels. This is your proprietary data you've built up over those decades of your organization. And if you take that data and you fine tune a closed model, the resulting model is owned by that closed source model vendor. So you are not able to download the model. You don't control it. Every month or so, the underlying model underneath it might change, and then behavior of your application change out of your control. But if you do it with an open source model, the resulting fine-tuned model is something that you, as the insurance company, own. And now you own your investment in generative AI and the future of your destiny built around generative AI. You can also control where you deploy it, if you have a multi-vendor strategy for who you host it with, and anything else. So we think that is one of the key reasons that a lot of organizations will build on open source. The other key reason we think that a lot of organizations will build on these open models is they can actually achieve higher accuracy at their task with lower cost. And so I mentioned at the start that the cost of generative AI is much, much higher than the cost of applications of the past. And if you need an AI model that's able to answer absolutely any question in any domain, in any industry, you need a very large model. And the closed models like Anthropic Claude, OpenAI, GPT-4 provide by far the highest accuracy at those tasks. However, most enterprises don't need that. They have one industry that they work within. They have one task that they need for a particular model. And so when that's the case, and this is what our customers are coming to us constantly with, you can take your private data set, fine-tune a smaller open model to that task specifically, usually achieve higher accuracy at your focused task than the big general purpose models provided, and then now have a small model that is much faster for your end users and much lower cost to operate. And so that's a frequent motion we go through with our customers, and why we think sort of the future will be that most organizations will do that type of motion and use an open model at the core of their application. So that I think answers the first part of your question, Sean. Why Together AI believes that the future includes open source. Do you want me to go next into sort of the differences between maybe open
versus open source? And you guys talk a lot about transparency. I mean, some of your models on your site must be fully open. Maybe others are not quite as open.
Yeah, no, that's exactly right. And I think it's a nuance that is often overlooked. So it's great that you're understanding that and asking that. We generally believe that the future is open models at some level. And the greatest level of that is essentially fully open source, where the code to build the model is actually publicly available and released, and so that anyone is able to use it themselves. The data used to build the model is also openly released, and the model itself, of course, is openly released. And in most cases, the open models, often referred to open source, don't include all three of those. In most cases, it's just the model itself, not the training code used to build the model or the training data used to build the model. And in that case, we would refer to that as technically being an open weights model, not an open source model. it still provides a lot of value because organizations can download it in their own organization, deeply fine tune it, and own any resulting kind of fine tuned version. But the models that go even further to release the training source code as well as the training data used really help the open community grow and help the open research around generative AI kind of continue to innovate much more than a closed source model or just an open weights model.
So as you were speaking, I was thinking about the fact that open source requires the organization to take more of an active role, right? Whereas closed, obviously, it's not that you're not active, but it's not so much involved. But my question had to do with the talent and the skill, right? Because if you have to take the active role, you need the skill, right? So right now, there's kind of like the skill imbalance is happening. So how can the future be open, right? If you don't really have the skill to work on the openness.
Yeah, and I think that's a great point, and that's really where we come in. At Together AI, we not only make these models very fast and cost efficient, but we also work really hard to provide a super simple developer experience to our customers. And this means that without any depth of AI knowledge, you can start using any of these open source models in your application just as easily as if you were using one of the big closed source models. We'll also make it very easy for you to fine tune one of these models to your task or deploy it with your own private data in a way that's called retrieval augmented generation, or RAG, so that without having deep AI expertise, you're able to make use of these open models very quickly and easily in your application.
Sounds good. So our next question really is that Together AI announced Meta Llama 3.2 APIs on the Together platform. What makes this model unique on your platform as opposed to it being on others' platform?
Yeah, that's a great question. So, Together AI provides the fastest, most cost efficient platform for using these Llama 3.2 models, and it enables enterprises to horizontally deploy those Llama 3.2 models across their organization in a way that is very easy to integrate through really simple developer experience and cost efficient compared to competing solutions due to the performance and efficiency that our platform brings.
Okay, so we're still speaking on open source, but then I have a question about how your cloud deployment comes into everything. But since we're still on open source, so there's long been this discussion traditionally about open source was seen to fall behind proprietary models because they're uh, easier to manage, better ways and more accurate to manage closed models, and most importantly, more support, right? Better support. You're a vendor focused on open source and open models. What's your view of that?
I think we're not seeing open source models fall behind closed source models. Rather, we're seeing open source models closing the gap in the difference in quality between the open models and the closed source models. That closing the gap has been far more rapid than we expected, and I think most expected in the industry, where today you have models like Mixtral, Llama 3.2, Llama 3.1, that provide almost on par accuracy across a number of benchmarks with the leading closed source models. And that happened much more quickly than I think we would have expected. In terms of sort of support for those models, there's a thriving industry starting to form around organizations like Together AI that provide support to organizations for how they use those models. And so we fully support helping the customer to deploy the model securely, integrating guardrails so that the behavior of the model is controlled and aligned to what the customer expects for their task, and manage any of the kind of operations with the customer for operating that model either in their environment or our cloud to meet their performance and SLAs.
Interesting. You've mentioned a little bit that support is really, I guess, the big thing behind Together AI, right? So is that the way that you mainly make your money?
I think this is a common misconception that if you're building a company around something that's open source, you're not going to be able to make money because the fact that it's open source means that it's given away for free. And the reality is that we've built our company around providing hosting services and deployment services for open source models. But we're not selling the models themselves. We're selling the service of hosting the models. And so while the model itself is free, you can download Llama 3.2 without paying anything, and you could start to try and develop with it on your laptop or deploy it to a server that you have in your organization to use. Once you get to the point where you're actually wanting to deploy that model at any kind of scale, you're faced with either paying for those GPUs that you host the model on yourself, either literally physically buying them, which is not very common these days, or renting servers from your cloud provider like AWS, GCP, or Azure. And these GPU resources are extremely expensive. Where we come in is that we provide faster and lower cost deployment on a cloud that we've built to be very, very efficient and very, very high performant, and enables organizations to deploy in our cloud at much lower cost than it would cost to do it themselves and operate it themselves on those rented GPUs on their own cloud. We also allow organizations to deploy our software inside of their own environment on either their own private VPC with their own GPUs or on premise on equipment that they've bought. And the benefit we provide there is very similar. Essentially, we can deploy for a large customer that may have been running a generative AI model across hundreds of GPUs, and we can typically reduce the number of GPUs that they need by half or more. And this is a tremendous savings for them as an organization. If they have hundreds of GPUs, this may be tens of millions of dollars in savings that we're bringing to them by deploying our software to manage that stack and give greater efficiency and performance. One final point, I guess, to add to that, the software we provide for hosting these models and the service we provide for hosting and operating these models is not open source. So we're not an open source company where everything we do is open source. We've built a company around creating proprietary, innovative technology for the hosting of open source models.
I find that very interesting because obviously there's another company which started that way that kind of, I guess, open AI, you, you know? Because so that's was my question, in terms of like, well, how do you make money? But when you talk about obviously hosting service, what would you say is the biggest pain point for your clients, right? When they're trying to host or trying to have these open models?
Yeah, great question. So most of our customers come to us after they have already gotten to accuracy and sort of product market fit or usage of some application built on generative AI. And often they will prototype that using, say, OpenAI or Anthropic or another closed source model. They'll see that AI is able to achieve the results that they were hoping. They're able to deploy it for a small set of users and actually have users engage and positively respond to the application and use it. And then they're now wanting to take it to the next level and deploy it for all of their customers or all of their internal usage of this application. And at that point, they start to run into several issues. One issue is the cost of using those APIs. Second issue is the actual performance and speed and things like rate limits so that they're able to meet the capacity of the volume of users that they have. And third is the privacy of their data. And so usually at this point, they're wanting to invest in using more of their own private data to further fine tune the model to achieve a little bit higher accuracy than they were achieving with the closed model. And as they start to try and deploy that on open source models themselves or switch from those closed source APIs, that's when they usually start to talk to us. And we are able to make it very easy to make that switch, bring you much faster performance and efficiency to them, and handling all of the kind of operations and orchestration of all the traffic on these models, which can be quite challenging on top of this GPU infrastructure.
I just want to change the conversation a little bit and go into who might be your competition. And I'm just curious, like, correct me if I'm wrong here. Maybe it's too blunt a question, but Amazon has Bedrock and Google has Vertex AI, and seems to me that clients could do similar things they do with you on those platforms. And I don't know about price, but I'm a little unclear how you can go at a lower price when they have the bigger scale. So they could, economies of scale. And then also, could you talk a little bit about your other kinds of competition, like open model providers themselves, maybe?
Yeah, yeah, absolutely. Great question. So we do compete with platforms like AWS, Bedrock, or SageMaker, Google Vertex, and similar offerings from Microsoft Azure. But we bring essentially this specialization in performance and achieving high accuracy of model quality without sacrificing that performance, and doing so with very high efficiency. That focus on performance and efficiency has really been what's helped bring us the success we've gotten to date. In less than a year, brought on 150,000 developers using our platform for this, and started to deploy for some of the largest technology companies in the world, sort of the biggest deployments of generative AI after the OpenAI, Googles of the world, the sort of top 10 organizations. One of those large technology customers was an AWS customer. And when they wanted to switch from operating it themselves on EC2 with their own machines to having someone operate it for them, they considered Amazon Bedrock, they considered AWS SageMaker, and they considered Together AI. And through doing a bake-off, we were able to bring something like 4 times more capacity per GPU than they were getting with the AWS services. And so that performance difference is just tremendous. Again, if this organization, say, had several hundred GPUs, we're talking about saving them tens of millions of dollars by switching to Together AI instead of using those services. And I think that this is where the surprise comes in, because traditionally, the infrastructure cost was quite inexpensive relative to the cost of the development of the application or support of the application, other things. But with generative AI, the cost of the infrastructure and GPUs has an outsized importance. It's a much greater portion of all the application development lifecycle. And if through our own research and innovations, when we bring, say, 4 times greater capacity than say VLLM or competing services from the hyperscalers, for any reasonable size deployment of generative AI, that makes a huge difference to the customer, and is the reason that they switch to use us instead of using the built-in services from their own hyperscaler provider.
Going back to our questions now, with Llama models, there's also a way for enterprises to build AI agents, right? We've been hearing so much about AI agents. What is Together's AI's definition of AI agents?
So essentially, you can think of an agent as any deployment of AI for a task that you're going to call programmatically to autonomously complete that task on your behalf on request. And so usually, instead of the end user chatting directly with the AI model and seeing a chat interface, with agents, you're going to have an application programmatically call some chain of an agentic workflow, a series of agent steps, and then the agent effectively act on that request and service that task for the application. And so Together has introduced a platform for building agents like this and building agentic workflows that allows developers to make multiple AI model requests and use them programmatically through what's called function calling, integrate it with their own private data sets through RAG, and then deploy all of that as an agentic workflow that their application can use and call programmatically. And one of the things that I think is interesting here is that performance and latency become even more important with agentic workflows in many cases. When a user is chatting with an LLM, the performance really only needs to be as fast as the user can read. And as long as the text is streaming in faster than the user can read, then it's really fast enough. However, with these agentic workflows, in many cases, the application that's making the agent call might have an end user waiting, but it's not able to act on the next step in the task until all of the AI model calls are completed, which might be a series of calls before the task is completed for the end user. And so the differences that we bring in making all of this very, very fast and low latency become even more important with agentic workflows.
Another question is that so how big is do you think that this new hot agentic AI going to be? To go back to what you mentioned at the very beginning, which is like you saw that generative AI is coming from the technology aspect of it. Did you also see this like agentic AI workflow coming in? To give an explanation for the previous question is that it seems like everybody seems to have a different definition of what AI agents is and is now just like another buzzword. So do you think it's going to last?
I think it's kind of an umbrella term for applications using these AI models through some set of logic that doesn't necessarily just involve a user chatting directly with the AI model. And if we think of it that way, I think that the adoption will last. I don't know if the terminology is the terminology we'll continue to use, but I think we're in very, very early days of organizations deploying generative AI for tasks in the organization. And I'm a strong believer that that's going to have tremendous adoption over the coming years. I think basically every application and just about every feature in the application will probably leverage generative AI in some way in 10 years from now. And I heard an analogy that I thought was a good one. It was that you could kind of liken it to the internet. Before the internet, we had software applications. You used software on your PC at home or your laptop or whatever it might be. And those applications didn't use the internet. When the internet came out, people thought of the internet as being, okay, like websites, and that you could go to a website or you could check email. Not that applications would change. But the reality today, of course, is that every application you use on your mobile phone or your laptop or your desktop computer uses the internet, and just about every feature uses the internet as part of that. And I think this will be similar to how applications use generative AI over the coming decade. And so we're probably much less than 1% adoption of agents or AI inside of applications in organizations. And we're going to see that grow significantly over the coming 10 years.
We've been writing about, Esther's been writing about agentic stuff for every week, like for the last month or two. And it came out of nowhere almost, it was kind of a stealth thing for about a year. Then I wrote a story about this RPA AI vendor, Orbi, who has agentic RPA things. And then everybody's got agentic. It just like it burst out into the open so quickly, it seems. But it seems like certainly a logical next step of applying this technology. But so could you talk a little bit about transparency? I mean, I know you guys talk about that. Do you work to make models transparent? Do you make your own processes transparent? And how does that differentiate you from other vendors with similar approaches?
I think partly this goes back to your question on some of the differences of the different types of open models. Open weights versus open source and open data. One of the things that Together AI does, in addition to providing our production services, is we make a lot of contributions into the open source AI community. That includes both releasing open data sets and open models built on top of those data sets that can be used by organizations directly or used by the research community to help further the quality and adoption of open source AI in any models that they're building or applications they're building. And so this is where we really work to enable tremendous transparency into what it takes to build these models, how we build these models, and the data that these models are trained on. One great example of that is we released at the time, at least, and I think maybe still to the day, the largest open data set for building generative AI models. We called it Red Pajama. It was initially created as an open data set to help replicate the Llama 1 models from Meta. And some of us were parents with young kids, and there was a story called Llama Red Pajama. So we named the data set Red Pajama, And this latest dataset version that we provided has over 30 trillion tokens of data with quality labels across all of it and metadata across all of it that allows organizations using that to build a model to automatically take different slices of that data to use in training their model. And it gives tremendous transparency into sort of the data that's used to build these models.
Speaking of red pajama, great
Yes.
name. My red pajama. That's funny. I did want to ask about red pajama. So can you go a little bit more in depth about what that data set is, and also how important is a quality data set when training AI models?
Our latest Red Pajama dataset contains over 30 trillion tokens of data that comes from common crawl web scrapes. And with that data, we computed signals across that. I think we have over 40 different signals across each token in that data set, each part of that data set. And those signals include the types of signals that AI model creators would use to select data from these web crawls. Some of that is signals like, similarity to Wikipedia. Generally, if the text is more similar to Wikipedia in its language, it's seen as higher quality and likely to be educational or data-oriented text. The amount of code that was in the data file. If you're not looking to train with code and it's mostly kind of JavaScript code as opposed to actual user-facing text, then maybe it's not a good data set to use, or that particular file is not useful to use. And then lots of others like harmful content detection and other categories. And it was pretty fascinating when we released this because 30 trillion tokens of data is just many, many terabytes of data. And so very few of us have enough space on our laptop or even our development PC or machine to host all of that data, let alone to process that data. Processing that data requires significant compute, and building a model on top of that data at the time we released it was probably over $1 million endeavor to build a model trained on over 30 trillion tokens. And yet, as we released it, it went quite viral in social media amongst the open source AI community and proceeded to get millions of downloads. So we were just shocked by this. I think that the engagement in trying to learn and use this data in the AI researcher community, the AI development community, is surprisingly large, and it got a lot of traction from that community.
Do you think that the traction that you receive shows that there's kind of like this hunger for something like that, Like there's a need for like to have everything be open? Because when you think about the start of with ChatGPT, right? We all knew that it was just data from all over the web, and that causes problems, right? And so, is that kind of like the response to something like that?
Yeah, absolutely. I think, and that actually gets back to the founding of Together AI and some of where our name came from. There's been significant advancement in AI research over the past several decades. And the way that advancement has all happened has generally been through open research, open publishing, and open sharing. In many cases, open source as well to share code for how to do different algorithms. And, when the Together AI was founded, June 2022, there'd been a recent explosion in capabilities led by OpenAI with GPT-3 at the time. This was before ChatGPT came out. But OpenAI had progressively become less and less open. They were no longer sharing really any kind of research paper around how they developed GPT-3. They weren't sharing the data that was used, the techniques that were used. They were being increasingly closed in terms of how this generative AI was being developed. And at the same time, or shortly after, Google Research announced internally that researchers were no longer allowed, for the most part, to publish research on generative AI, or that it needed to go through like the highest level of approvals. And so the number of papers coming out about real techniques to build generative AI models was diminishing tremendously. And this was incredibly frustrating for everyone in the research community, because the research community was really built around this open publishing and open sharing to help advance AI. And there was tremendous excitement for the quality that was being achieved and the results that were being achieved, but a lack of information on how it was being done. And so the open community was trying to replicate these things with as much information as it could get from anywhere. And so I 100% think that the reaction to the traction that Red Pajama received was because of that hunger for more openness from that community. And since, I think you've seen organizations like Google become more open, they've released Gemma, for example, a fully open source generative AI model. And I think that we'll continue to see that open community grow and get closer and closer to achieving the results that any of the closed source models are achieving.
Do you think that being competitive is, I guess, synonymous with being like not open? Because that's kind of what you described earlier when we talked about the progression of like OpenAI becoming more and more open. At the same time, they're growing, right? And then Google also decided to do the same thing, but it kind of as reverse. So, what is your thoughts on that?
Competitive motivations could cause an organization to become less open. Certainly, if they felt that the quality of the generative AI model and the techniques used to develop the model itself were their competitive advantage and their secret sauce, they may not share those openly anymore. And if their focus was, competing as providing the best model and competing on, the use of the model, then that could cause them to be less open. At the same time, I think that there are organizations who embrace open source as a means to compete. And that's one of the things that I think is it takes a little bit more kind of in-depth thinking on what's actually happening to come to that conclusion. But there's a lot of examples in the past of open source projects that gained higher quality, larger ecosystems, and more adoption through the fact that they were open source. And that enabled the organization to be even more competitive by open sourcing that project. And if their business is not reliant on sort of the thing that's being open sourced directly and the secrets that are being open sourced, but instead on building on top of that, building an ecosystem and applications on top of that, then you can still have a strategy that allows you to compete while embracing open source.
I'm going to ask you a question looking forward, and then Esther's going to wrap up soon. So what does the future look like for Together AI and for open source and model transparency?
Yeah, great question. I mean, I've never experienced anything like the growth that's happening right now in adoption of generative AI and the growth that's happening in Together AI as a startup, starting to lead in that space. And so I think that the future is incredibly bright. I'm so excited for what the future holds for Together AI and for the adoption of generative AI in businesses and enterprises in general. I think Together AI will continue to build for large enterprises, a platform that is able to do more and more of the Gen AI development and hosting stack, and continue to make it really easy for those organizations to deploy that at scale with high reliability, performance, and cost efficiency. I think that open source will continue to thrive in AI. As I mentioned, I think more organizations will probably build on top of open source models as opposed to closed models for their core of their generative AI investment. They can achieve higher accuracy by tuning a smaller model and then own the resulting model. And deploy it with lower costs than using the larger general purpose models in most cases. And I hope that the trend of transparent open sharing amongst the AI community and research community continues to grow. I think that it went through kind of a time of very little transparency and very little open sharing, and we're starting to build back up to where it once was in terms of the open research and open sharing that happened previously. And I hope that'll continue. I think that'll be good for AI research. I think it'll be good for society in terms of how we evolve with these technologies. And I think it'll also be good for organizations that are deploying these models, having better transparency into how they will behave and how they are built.
Thank you.
Thank you so much, Jamie. We really do appreciate your time, taking time out of your day and to just come and speak to us about this topic of open and open source. And you kind of broke it down. Where can our listeners and now our viewers catch up with you, Jamie?
You can catch up with me. I'm Jamie at together.ai is my email in case you have questions for us. Or you can reach out through LinkedIn or Twitter as well.
That's great. So thank you so much for joining us. Please feel free to our listeners and our viewers to leave a review or to leave a comment. TechTarget's YouTube page, High on Tech. Please continue to share and to like this podcast on all your social media platforms. And we will see you next time on the Targeting AI podcast.